hey, thanks everybody for coming. I really do appreciate you taking time out of your busy days to listen to us talk about avoiding SQL Server virtualization pitfalls. My name is David Klee. I have been virtualizing SQL Server for approximately 15 years now, since right around the time that VMware Workstation was still in beta. There's a number of different ways to get in touch with me here. I am lucky enough I was awarded the VMware vExpert title last year and applied for it again this year. I do a number of things around performance tuning, virtualization. I am the owner of Heraflux Technologies, so there's a lot of different things here that I can do around performance tuning, virtualization enablement, things like that. Peter, did you want to introduce yourself as well?
Sure, absolutely. This is Peter Kerr. I am Senior Director of Strategic Alliances here at Tegile, and we are very happy to have David here to discuss the challenges that he has experienced throughout his career. At the end, we'll touch on some ways, obviously, to solve them and give you some tools during the time. We will pause periodically during the talk. If you want to and you have some questions, please do not hesitate to type them into the chat window. You can direct them to everyone, or you can direct them directly to me. It's Peter Kerr, and we will pause, every 5 or 6 slides and answer some of the critical ones that we would like to do. And David, take it away.
Okay. So what are we going to talk about today? We're going to talk through functionally, from a SQL Server DBA standpoint, what really is virtualization and what are the realities as a DBA having virtualized systems. We're going to talk about just the different perspectives that we as DBA have versus some other organizational groups inside the organization. We're going to start talking about a lot of these really serious topics that can all negatively affect SQL Server performance and virtualization, most specifically around the compute resources that we know that SQL Server so desperately needs may or may not be there when you virtualize this because there's some different priorities going on. We're going to talk about some of the silent performance killers when it comes to right-sizing SQL Server virtual machines. And then we're going to talk about what happens when you stack a lot of these virtual machines onto a physical environment and what really happens. Then we're going to talk through the Tegile storage solutions and how a lot of these little pitfalls and things with SQL Server virtualization really can be worked through with better hardware. Okay, so functionally, from a DBA standpoint, just what really is virtualization? There's a lot of misconceptions and misnomers out there around what it really is because as data professionals, we may not necessarily have a lot of hands-on access to the hardware of these virtualization platforms. So functionally, all it is a small added layer between the hardware and the operating system that turns these physical machines and a group of these physical machines into a collection of resources. That's it. Your virtual machines at that point simply get in line to get access to the resources they need. That's functionally it. All these other things around it, they're all bells and whistles for management and orchestrating and making things more streamlined. But functionally, it just turns hardware into a resource queue. That's it. So the big players today, you've got VMware vSphere, Microsoft Hyper-V. They're both fantastic platforms. You've got some other ones. You've got OpenStack and Oracle VM and Zen Server and Red Hat virtualization. They're all built off of the KVM platform. They all do great. I'm not going to tell you what platform should work best for you. I say they all work really well. There's differences in the platforms. There's differences in the way the organizations manage them. Use what works best for you and your organization with what skill sets you have in-house. Now, the history behind the virtualization platform is where things get interesting today, knowing where they come from. Functionally, in the past, the #1 draw for virtualization was around consolidation. So you could take a football field-sized data center to one row of physical machines, and it would run equally or better than it did before. Now, most of the time, they were, at first pre-production, very simple product file servers, print servers, things like that. Those all got virtualized first, and if there is a small performance hit, it probably didn't matter because probably nobody even noticed. But now we're at the phase of this virtualization freight train where the last remaining things to be virtualized into your private cloud are really these big business-critical applications that everybody loves to fear, like SQL Server, Oracle, SAP, these massive Java applications, all these things now. This is what's coming last. And this is what we focus on the most because virtualizing those is very different from virtualizing a file server or print server. Now, like I said before, instead of focusing on a single physical machine and the resources assigned to that physical machine, it's now a collection of resources that you have at your disposal. So in this demonstration, we've got just a bunch of CPU, 4 terabytes of RAM, a lot of flash-driven storage, solid networking, and then what you do is go through and you start to carve up and allocate those resources as you see fit based on your workloads. It's a little bit different mindset there because if you need more resources, rather than having to upgrade that physical machine and go through a really painful process, of migrating everything to a new platform, you simply add more resources into the pool and then tell things to load balance. Now, the realities here are really interesting. So when SQL Server virtualization is done right and done well, the ROI is huge. I mean, the platform consolidation is one, but the licensing savings is incredible. I did an analysis a little while back where we took a SQL Server 2012 license upgrade. We planned to virtualize everything and was going to bring the cost from over $24 million to $6.5 million, and we claimed equal or better performance. It's huge. You've got so much better flexibility and agility. So what's better, migrating a physical platform to a new piece of equipment? It's a big project, there's downtime, or 2 clicks? I go with the 2 clicks. That flexibility gives you better HA, you're more protected, you're less vulnerable in the event of hardware failures, and you've got much easier disaster recovery. Now, there's flip sides to everything. Problem here is if it's not done right, I can guarantee you that you will have performance degradation. Problem is, it's not something that you're going to be able to see in an event log or a DMV. Most of the time, this stuff is silent and it's random, and that's not good. And because in a lot of environments, virtualization to the DBA is a black box, it's a lot harder to troubleshoot, and there's a lot more finger pointing, and it gets very, very challenging very quickly. Now, that's a worst-case scenario. Most of the environments I've seen, they're somewhere in the middle, where a lot of times, they may not have direct access to the virtualization layer, but they probably work fairly well with the other teams. It's just more to handle when it's not done properly. Now, when it comes to the pitfalls around virtualizing and managing this stuff, there's some fundamental differences in those organizational silos. You've got networking, you've got storage, you've got security, you've got a system administration group, you've got hardware admins, and then you've got the data teams, and then you've got developers, and they all have different expectations, they all have different priorities. Things get a little interesting. There's also the big push, and we'll talk about this here in a second. When it comes to physical machine resource issues, it all comes from consolidation and overcommitment of physical resources. The biggest one that I see comes with shared storage, and that's where things get really interesting. Now, from an organizational perspective, from a DBA perspective, we have a number of priorities that we know we have to achieve. They're dictated to us from management. We know as DBA professionals we have to do those no matter what. Now, the systems and virtualization groups, they have their own mandates. For us, the number one thing that we are really driven to do is make sure that this data is available. A very close second is make sure it performs well. Now, the system teams, performance is not necessarily their top concern. availability is the first one, but consolidation, making sure that they can squeeze the most amount of virtual machines into that physical stack, that's their big consolidation. So as a result, if you were to ask a DBA, what's better, faster CPU cores or more cores? The systems groups are going to say more cores because they know they can squeeze more VMs in there. The DBA, especially with SQL Server licensing, is going to say faster, not necessarily more. So it's a fun balancing act to meet in the middle there. Now, from a DBA perspective, usually a DBA is not expected to be an expert at the infrastructure underneath their data. So there's a lot of nuances with every layer of the stack. The DBA really shouldn't be aware. They should know how to troubleshoot what the impact of some of these nuances are and be able to help direct the troubleshooting group. But they don't necessarily have to understand the nuances of the infrastructure. And the same thing goes for the system and virtualization admins. There's so many different types of applications out there. They just can't be aware of the nuances around the applications that they're putting on their platform. Now, that's, to some extent. They need to know that SQL Server will consume every bit of resources that you can give it if it's not properly tuned. But, and they also need to know the impact of what happens when one of these things can go wild. But we'll talk about that more in a little bit. Now, from a functional perspective, me as a DBA, if I'm going to virtualize something, I expect at least equivalent performance from what I'm coming from. Otherwise, the impact of doing this may be such that people start complaining, or reports don't run as long, or ETL packages fail. There's all kinds of problems with it. Now, on the flip side, the system admins, they don't necessarily have that methodology for doing this performance testing. They just virtualize and generally forget about it. And of course, everybody's budget constraints. You're trying to make the most out of what you have available. The goals are the same, is to service the organization properly, but it's just massively different perspectives. And that consolidation mandate from a system admin and a virtualization admin, that is the number one thing that really gets folks into trouble when they virtualize a SQL Server. The environment is designed for maximum consolidation and not consolidation while maintaining performance. Okay, do we have any questions up to now?
No, David, we don't have anything yet. Again, ladies and gentlemen, just send questions to all panelists, and we'll queue them up and periodically answer them. Thank you very much. Okay.
So from a functional standpoint as DBAs, the number one thing that I say is let's open up this black box a little bit. A lot of times, DBAs cannot see what's actually going on at the virtualization layer. So I like to joke that I like to fight for DBA rights. No matter what, get access into the management console for that virtualized environment. It doesn't have to be anything fancy. I mean, most of the time I say get read-only access, and it's just for the virtual machines that really your job depends on. It may even just be production. Ideally I want everything. And get the access to the hosts that they live on as well. Now, read-only, it can't do anything. The other thing I always say, if you're going to get access to it, that's great, but now we need to go through a little bit of education so you understand what you're seeing there, so you know how to interpret that, and then start to overlay what you see there with what you get out of, say, perfmon and SQL Server DMVs, things like that. And that way you get a much better picture quicker of what's actually going on with that virtual machine. Now, the stats here, from a VMware standpoint, this is just a screenshot out of my VMware home lab. On this cluster, you can see that from a normal day-to-day management standpoint, this is what the virtualization admin sees. And they see the amount of CPU used, the amount of memory used, and the amount of storage used. It does not give you that whole picture where this chart could look perfectly fine here, but you may actually have a SQL server that's got a 10, 20, 30% performance hit, and nobody's going to see it until you dig in there. With storage especially, a shared storage thing is a killer. the fun thing is I do a lot of webinars and sessions, SQL Saturdays and things like that, to really help DBAs go through and understand these private cloud virtualization concepts. And that way it makes you a lot more efficient when you go through to troubleshoot. Really, if there's a performance issue or if there's something a little funny, it helps you go through and figure out what's really going on. So that's step number one, is get access there. The next step ongoing is you need to be doing ongoing performance collection inside your virtual machines as well. We'll talk about that in a little bit. But you can overlay those stats with this, and you can start to trend and see, do I have problems going on in the background that may be negatively impacting performance, say, overnight when a corporate antivirus scan runs on 5 VMs in the background, but they're on the same physical machine? What impact does that have to my SQL servers? A lot of correlated events like that really do start to matter once you start virtualizing and consolidating. Now, I said before, the biggest problem that I've got with a virtualized SQL server is it's this historical push for consolidation. And the consolidation aspect of virtualization is phenomenal. You make the best use out of the equipment possible. I mean, most of the time, you buy a physical machine, you size it for what you think it needs at the end of the lifespan of that machine, and for the most part, it's a Porsche just sitting in a driveway, and every once in a while you run outside and stomp on the gas, giggle a little bit, and run back inside. Functionally, these machines are just idling. So when you start piling things on there, you get the most efficient use of that platform. Problem is, when it's gone too far, and instead of gracefully putting VMs on the physical machines and letting it load balance, it's basically trying to squeeze as much in there. You get what I call host resource over commitment. And it's basically, I may be constrained on memory, or I may be overwhelming a path to storage, or I may be having so much in my resource queues that things are taking longer and longer to run. When you start putting big Tier 1 platforms on there, they are so resource intensive that if there's any underlying problem in that infrastructure, it's only going to get worse. The problem is the impact of improperly sized VMs or resource overcommitment or choke paths, again, awful, awful silent performance killers. Now, there's a number of things that you can do to start to correct this. A lot of times people have given a virtual machine the same amount of resources that they did a physical machine when you have a lot of resources that are just sitting there idling. That's actually a bad thing. We'll talk about that in a second. So it's, incorrect resources on the VMs, or a lot of this altogether, so you've over-allocated CPU or memory. And then you know how heavy SQL Server is, especially when you do index rebuilds or a lot of OLTP reporting or OLAP cube builds, things like this. When you run all that together, you can overwhelm all kinds of storage. And then on top of all that, over the span of a week, what do you get? You've got, let's say, weekend reports running over a weekend. You've got Monday morning everybody coming in and hitting things differently. You've got things idling. You may have system-level backups each night. You may have database backups, fulls on the weekends, and all these different things. The workload is all over the place. It's really hard to pin down. It's pretty much random. So it's very, very interesting. When all the stuff adds up, you get a lot of funny issues. Now, when I say misallocation of compute resources, functionally, this is an example of that overcommitment. So say it's a virtualization cluster, 5 physical machines, 20 cores each, 256 gigs of RAM. It's a good, solid virtualization environment, and you can squeeze a lot on there and get pretty good performance out of it. The hard part is when you start putting some of these SQL servers on there, if the storage can only do 30,000 IOPS total, and that's on a good day, if they are used to local solid state or, lots of direct attached storage on their physical SQL servers, and you go to virtualize them, these things can overwhelm an existing SAN pool. Problem is the impact of everything else running in there hurts it even more. So in this demo, or in this screen here, we're already overcommitted on memory. We're destroying the storage, and the CPU is way overallocated. Okay, so functionally, what happens now? All of these massive workloads are funneled into a much smaller subset of equipment. So the impact of any one thing is going to get magnified. I mean, be it a storage path or memory access or all these different queues that the physical machines have to allow these VMs to get resource access. Now, I joke about something called noisy neighbors, but what a noisy neighbor is, let's say I've got 10 VMs on one physical machine. What if somebody's going and doing a massive, really long-running report that's just throttling, all the resources given to one VM? Well, what's the performance impact of all that activity on the other VMs on the same machine? It gets really interesting, really fast. Between that, and there's some things that need to change a little bit. When you have a physical environment, you may kick off an antivirus scan, every night at midnight, and that's cool. It's a separate standalone machine. Well, what if these workloads are now set to run at exactly the same time on a physical machine? This is where it gets really interesting. The CPU consumption is huge. The raw throughput on disk can just destroy stuff. There's one funny example I've got with this. I was at a customer site a while back, and they had a massive site. They had approximately 21,000 virtual machines. They're huge. And somehow, I'm there in the middle of the day, and one of their virtualization admins accidentally kicked off a real-time antivirus scan on every VM. And all of a sudden, we watched all the machines in the data center. We're in the corner in the data center working on something, and all the machines, the fans just spun up all at once. And the whole room just got really loud, and people were running around trying to figure out what was going on. Stuff was getting impacted. It was pretty bad. Just the impact of it's pretty rough. Now, a lot of times with the aggregate workloads, you can do some tuning here to really, just good, solid DBA practices. You can turn on table-level compression. You get a slight bump in CPU, but the disk impact is lower, lower memory, it's proper index maintenance, more virtual disks, things like that. But the problem is you can only take the infrastructure so far. You can only take the workload tuning so far. You put all this together, if the infrastructure underneath is not capable of sustaining basic activity, you can tune queries and table structures until you're blue in the face, and it's not going to make a tremendous impact. Hard part here is if you have workloads like that, when you go to virtualize this, you may have just moved all those bottlenecks with it, and that gets kind of rough. Okay. Now, you heard me say the phrase right-sizing VMs before. What do I mean by that? Functionally, when you size that physical machine, when you go to spec it out, let's say I need, I think I'm going to need 8 CPUs at 3 gigahertz at the end of the life, so 3 or 4 years from now. I think I'm going to need all this memory. I probably need more storage than what I can afford. That's kind of the mindset that you have going into it. In the virtual world, things get really interesting. If you assign those same resources, when you project what you need instead of what you need right now, you will actually slow that virtual machine down. I have a case study a while back. We took a brand new SAN, brand new host, one virtual machine. We kicked off a DVD store synthetic workload that was designed for 8 CPUs, and we ran it. We got a performance number. We turned it off. We reconfigured that virtual machine for 32 CPUs. Now, the workload was still only going to use 8. We turned it on, ran it again. Problem here, we had a 21% slower running virtual machine. And I know that sounds weird, but here's what was going on. There's all of these resource scheduling and resource queues that happen underneath. So from a SQL Server standpoint, SQL Server was still only going to consume those 8 CPUs. Problem is, Windows now offloaded the things like storage access, network access, background system processes. It offloaded all that onto some of the idle CPUs in that virtual machine. And then there were CPUs that were just flat out doing nothing. the hypervisor, that thing underneath the OS, detected these idle CPUs, and it actually started to deprioritize some of those threads in favor of the more active ones. The problem is some of those active threads depended on things going on in the idle threads for things like CPU, CPU scheduling, NUMA balancing, disk access, stuff like that. So the net effect was an actual performance hit. And this is why I say you've got to right-size that virtual machine with what you need right now. You can always add more resources down the road. And if you don't have them available, you can physically add more equipment to the virtualization cluster, and now you have more resources at your disposal. Now, when you go to do this, it's a very, very good idea to understand the hardware underneath, because if I give a virtual machine, let's say, 4 virtual sockets, each with 2 virtual CPUs, if the hardware underneath is a 2-socket physical machine, each with 4 cores, I now have stuff jumping all around to get scheduled underneath, and there's a performance impact and overhead of that. I actually did an analysis just last week that showed it was a 2, 4, 6, and 8-way virtual machine with 16 CPUs and just different configurations. And we showed that at basically an imbalance, where it was a 4-socket machine, and we built an 8 virtual socket VM, each with 2 vCPUs, and we showed a 31% performance hit on an average workload. It's pretty substantial. Now the hard part is, ideally I like to do this before you virtualize something. I call it a right-sizing analysis. So that way you get a good sense for what's really going on underneath the covers. And then you can project, hey, I need a VM. You know, the physical machine is 16 CPUs. So I believe that I only need, let's say, 5 CPUs, and it's going to perform properly. Hard part is, you all know, SQL Server workloads constantly change. I add databases. The reporting may change. Applications get upgraded. All these things. So it's not a set it and forget it kind of a process. What I like to do is to do a quarterly analysis to say, hey, how much has the workload changed, and do we need to modify some of the resources to maximize performance? Now, I've got an in-depth analysis here. It's kind of dull. It'll put you to sleep. But it's a good read. It shows you the impact of a right-sized versus wrong-sized VM. Now, again, when it comes to right-sizing this stuff, it's all about understanding resource scheduling. The hard part here is normally resource scheduling is mostly viewed by CPU and memory, but storage still has a huge impact here, because if you have heavy storage latency underneath all of this, those threads can't get executed as fast. The virtual machine layer detects this and will reprioritize those resource queues, and again, it's going to slow it down. Do we have any questions up to now?
No, David, we don't have anything queued up yet.
Okay. Okay, so here's just a quick example. This is what happens with those resource queues, and this one's focused on CPU. In this case, just one physical machine. You've got that virtualization layer on there, and you've got 8 VMs all carved up the way you want. In this case, what I'm focused on is the CPU queue. So in this case, it's a virtual machine with a task. The task is ready to get executed. So we're going to submit that task to this queue. Pretty straightforward. If there's not a lot in that queue, it's going to get through that nice and quickly. The problem is, when you have a decent workload on the machine, you may get more things in that queue, and it takes a little bit longer. On a heavily consolidated environment, where you've got too much running, that queue is going to be huge, and it takes longer and longer and longer to get through that queue. And if things aren't properly balanced, things can jump around in the queue and maybe cut in line or get deprioritized. Now, the fun part here is that the different hypervisors actually give you the ability to measure the impact of that queue. And Peter has some queries. If anybody's interested, just give him a quick shout out, and he can send you the queries around how to measure this stuff. When it comes to VMware, now there's a Hyper-V equivalent coming in just a second. When it comes to VMware, VMware calls it CPU ready time, and it's very simple. It's the amount of time per VM, per vCPU, spent in that queue. Now, the VMware polling interval is every 20 seconds. So functionally, if I have a number here, it's measured in milliseconds spent in that queue per 20-second polling interval. So to translate that, if I have a CPU ready time of 1,000, you take that 1,000, divide it into 20,000, and you see 5%. So at a gross CPU penalty, that's a 5% loss in performance, and it's silent. You will not see it in an event log. You won't see it in a DMV. The hard part here is that's a gross loss to the VM. But now what happens if you have that on every vCPU, and you will? The net effect of SQL Server, since it's so latency sensitive around these resources, it may be a 5% net loss from the metric here, but it might actually be more like a 10 or 20 or even 30% performance penalty, sometimes even more, to that virtual machine. And it's all a net effect of not assigning the right VM resources to the VM and then putting too much of that on that physical machine. Easy to tune around, easy to clear up. I actually once saw this value at over 230,000. I kind of got a bad look from folks when I held up my cell phone and told them I had a faster SQL Server for them. That night we took everything down, did some tuning, knocked it way down. That's the fun part. Now, this is available from the front end in the vCenter management console. That's that management piece for VMware. Now, I mentioned before you need to get access to this, and just a simple read-only level of access will do. If for some reason that the folks in your infrastructure decide that you shouldn't have access to that, a little tidbit. Most of the time, the VMware vCenter database is a SQL Server database. And you can actually go through and get access to that database because you're the DBA. You need to make sure it's being backed up properly and do maintenance, right? Well, email Peter. He's got some questions, or he's got some queries that will actually give you these values straight out of that database. So you can kind of work around the system, but it's going to give you the information that you need because your job depends on it. Now, from a Hyper-V standpoint, it's the exact same metric. It's the performance counter. They call it CPU wait time per dispatch. Jonathan Cahias had a really good write-up there. It's available in Hyper-V 2012 and above. I'm sorry, but they didn't expose that in Hyper-V 2008 or 2008 R2. Now, it's not quite as easy to get to, but if you've got SCOM, System Center, Perfmon, whatever works, you can go through and just measure off that counter, and then life is good. It's really just, per polling interval, here's the wait. It works really, really well. Anybody have any questions about the CPU wait time? Because it's kind of a big topic there.
We have a question coming in. How can we reduce disk I/O usage? What are some of the things that we can do, to rely on disk a little less than we need to?
You bet. Well, from a disk usage standpoint, if you're looking at the SQL Server level, you can do table compression. You can really tackle the indexing strategy because that's always huge. If you have proper covering indexes, you will do a lot less I/O, potentially even a lot less memory. It could be as simple as giving the CPU or giving the SQL Server the right amount of memory to hold the right amount of data in memory. There's things like column store indexes, a lot of different ways to help reduce disk activity, all the way down to query tuning. Now, from a virtualization layer, if it's not a SQL Server that's chewing up activity, and I've even seen weird stuff like a syslog server was going berserk and just destroying a SAN that really wasn't built for it, you can actually use some things at the virtualization layer to say this VM can get no more than X amount of IOPS or X amount of throughput, and you can start to reduce the I/O impact. Now, in a SQL Server, you want the SQL Server to have all the I/O that it really needs, because if you don't, it's guaranteed to perform poorly. It's basically being more efficient when the environment is the direction you want to go there. A lot of times, though, with non-data related products, you may not have the tuning opportunities available to you, so you have to kind of resort to the brute force method of just slow down VM. Did that answer your question?
David, sure.
Okay, cool. Okay, so we
have one more. I would like to baseline the performance on SQL Server at a VM level. Do you have recommendations on metrics to collect?
I do, and if you hold on just a few more slides, I actually give you everything you need in order to baseline where you're at. So you're good. Okay, so we talked about CPU. We're going to move into we're going to talk about memory for just a second, and then we'll roll into storage, because storage, a shared storage component, is the #1 major issue that I have with a virtualized environment. Up front here with memory, though, there's another big one. A lot of times, okay, just an example. Let's say I've got a physical machine. It's got 64 gigs of RAM. Now, from a functional standpoint, I can deploy 10 VMs onto that physical machine, each with 10 gigs of RAM allocated to it. So it's 100 gigs of RAM total. The physical machine's only got 64. Guess what? It's going to work. Problem is, what happens when those VMs actually need all the memory they've been given? That physical machine can't sustain that. And it goes into some memory reclamation mode that is pretty awful, because what it does, it forces these VMs to start paging. Now, VMware is a platform that lets you overcommit. It works out really well because most VMs don't use all the memory allocated to it. Now, SQL Server, you know that it'll hold on to all the memory that you give it if the workload is demanding that. On the flip side, Hyper-V doesn't let you overcommit memory, but it does have something called dynamic memory, where if I give a VM 10 gigs of RAM and I have dynamic memory enabled, and all of a sudden that VM thinks it needs 12 gigs of RAM, well, it can actually dynamically give that VM more temporarily. And that's all fine and dandy. But what if I've got an antivirus scan running that's going to consume gigs and gigs of RAM per VM? And if they're all set to run at the same time again, that host may also go into a pressured state. Now, when this happens, the VM is going to be forced, or at least try to be forced, to give up some of the memory. And it does this by forcing the VMs to start paging memory out to disk. It's called, in VMware, it's called ballooning. Windows is called swapping. It's really, really bad, because if SQL Server thinks something's in memory and it's actually on disk, you have this double whammy while it goes and does a lookup, and it's awful. What I say here is that keep track. You can actually keep track of this from inside that virtual machine, even if you don't have access to that virtual layer. So in Hyper-V, there's a counter here called Hyper-V Dynamic Memory VM. It's just a simple perfmon counter under memory. You can track that really easily and see what it's actually doing. On VMware, same exact thing. Under VM memory, it's added when you add the VMware tools. It's called balloon. If that balloon value is greater than 0, watch out. Run. Don't walk to your virtualization admins. The hard part here is that the SQL servers are always going to be targeted first for memory reclamation. And there's actually a write-up on my home blog from about a month ago that shows SQL Server buffer pool memory is identified as inactive and stale memory from within the hypervisor, because it's just sitting there being used as basically cache. So, of course, I've got 100 gigs of RAM just sitting there. The hypervisor smartly is going to say, I don't have application awareness, but you've got all this memory sitting there. It's going to target the SQL servers first. So I always say, when you're deploying a production SQL server into a consolidated environment, or even a dedicated SQL Server environment, I want absolutely no memory over commitment to be even possible in that environment. Not only that, I don't want a single physical machine to ever go above 90% memory consumed. And that is because if it goes above 90, that's when these platforms start to go into memory reclamation mode, and that's when things get ugly. Now, on top of that, when it comes to storage, it's not just storage, but it's also the interconnect. It's the path to get there. I've got a quick story, just an example. A customer called up a while back, and they had SAP on SQL Server on VMware, and it was, quote, running slow. Fun one. They had, in a nutshell, they had spent almost $2 million on a brand new SAN and a whole bunch of services around it to try to figure out the problem. And they had this awesome SAN, awesome physical equipment, and they had a 7-year-old 4-gig fiber switch in the middle. And there were about 100 people in their warehouse that would have to sit and click through a query that was timing out. I went through and identified the switch, and we upgraded it. And sure enough, the query went from 10-minute timeouts to completing every time in less than 20 seconds. So now you've got 100 people that were actually able to go do their job properly. So I always say when it comes to the interconnects for storage and networking, get the fastest possible and get the most possible, because it's one of the most commonly overlooked components of that infrastructure, and it's just as important as a fast SAN. If there's multipathing, use it. Every vendor out there has some tuning guides for SQL Server, be it physical or virtual. Follow those. You can test the end-to-end performance of the stuff, especially networking, to validate that everything's going well, because you'd be amazed at the amount of stuff that gets deployed without actually getting tested. Now, I like to go through, there's a utility. I've got a how-to guide here called iPerf. It's free. It's for Windows. You can validate your networking performance, and it works out really, really easily and really well. You just set up 2 endpoints, point A to point B, and do a test. Really, so it is what you expect. It works. Yes, sir.
David, before we move on, we do have a question here that's very specific to a previous slide. Before we move off of this slide, I just want to add, validate with the vendors that you are using, both for your networking and your SAN, that they do really have true multipathing, and they can give you a document that explains how to configure it on the VM host, or on Hyper-V, or that they have a specific plugin that configures it automatically. There is very few vendors that are actually integrated into the default VMware system. And, there are certain steps that need to be taken to turn on the multipathing every time you add additional new, full physical server hosts that are then running the virtualization. So validate with them that they already have that. It's one of the things to keep an eye on because it can severely limit your performance, in the virtualized environments, even though perhaps in physical environment it's working just fine. Now to the question. The question was, I have an ESXi host. It's 2 times 6-core CPU sockets with hyper-threading enabled. I have my SQL Server VM to 6 vCPUs, 1 virtual socket, 6 cores per socket. Is that correct? Or should I have it set to 2 virtual sockets, 3 cores per socket? Also, my NUMA is set to 6. Is that correct? Yeah.
That's a very, very good question. If it were me, and this is one of those things, it is very workload specific. If you have a highly parallelizable workload, then that may actually be the best configuration. However, what I'd like for you to do is to stress test that machine with that exact configuration, and then do it again with 2 virtual sockets, 3 virtual cores. And you are probably going to see a little bit better performance out of the 2 virtual sockets. If you do that, what you want to do, and actually if you hit my home blog at davidklee.net, there's a write-up about a month ago, and feel free to contact Peter if you have any questions with this. But if the host platform is VMware or Hyper-V, you will need to set an advanced flag at that VM to extend NUMA into that VM. The reason I say try to go with the dual socket thing is because right now you have a virtual machine that's effectively trying to span NUMA nodes underneath the covers, even though you've told it to only do the one. Because if you come close to filling up an entire NUMA node, that could get interesting. Now, when you do that the twin vCPU thing, the socket, you want to test max stop of 6, as you mentioned, and you also want to test that at max stop of 3. The 3 is the number of cores in that individual NUMA node. So test both. I would bet a lunch that you're going to get a little bit better performance if you've set up the dual virtual socket properly.
Good, David, and we need to speed up a little bit so we can finish.
Yep. Okay. There's some performance counters here. This is all the things that you want to get out of Perfmon, be it VMware, be it Hyper-V, or really everything inside Windows. And I also have a guide how to set up Perfmon and get rid of some of the little gotchas with it, just down at that link at the bottom. The other thing here is overlay these VM performance counters with the stuff that you see at the physical machine, because there's overhead on every one of these pieces. It's very small, but it's there. So the in-guest stuff gives you a picture of what that VM can see, but not necessarily the whole picture. Okay, when it comes to storage testing, and this should answer the question from earlier, what I like to do is you've got Perfmon running. You know now you've got IOPS, you've got throughput, you know the usage patterns of that storage. Let's stress test that storage. So the tool that I love to use is SQL IO. It's free. It's from Microsoft. It's been around forever. It works great. There's a utility here that I like to use called SQL IO Batch, and it's just a PowerShell script that goes and tests different permutations of disk activity. What you can do is if you graph the averages of the operations per thread, you can get a graph very similar to on the right there. Now, the graph here shows IOPS and operations per thread. The little arrow with the question marks next to it, this is what happens when you have storage performance underneath the virtual machine that's not necessarily designed for this. On our test, we were throttling this thing so hard that we actually filled up a SAN controller cache and caused it to fill up, and the performance started to take a nosedive. Now, the big thing is, like I mentioned before, the storage has to be able to handle all kinds of stuff. All those different disk patterns, all the different activity at different times of the day. You need to have storage that can really handle all this. The performance has to be able to move where the hotspots are. Peter, did you want to add any more to that slide?
Yes, David, of course. So, one of the things that is important to keep in mind with traditional storage, and a lot of you have addressed some of these challenges by buying, in-server PCIe solution, PCIe cards, or put some SSDs in to offload some of that work. But in traditional storage, a storage admin will basically intrinsically define the performance of each LAN that they give you. They will string together 5 drives, each one of them giving 100 IOPS, so you get 500 out of that. Or they'll give you, 10 drives, and that gives you, 1,000 IOPS. Now, some of those may be slightly accelerated if some of the data happens to be cached on the controller of the SAN, but because that usually spans, 100, 200, 400 terabytes, it's usually very unlikely. And this intrinsic performance that's defined for each one of the LAN actually becomes challenge over time. What if one day you need part of your SQL Server or one, implementation to run really quickly, and on Friday you need the payroll to run really, really quickly, and over the weekend you need the database rebuild to run really, really quickly. And each one of these LANs that you are using for the system actually cannot scale the performance dynamically. It's very difficult to add new drives to it, and some companies, some teams do that at the end of the month when they do month-end processing, and they do this reallocation. Some SANs have something that they call steering, and they say that that's the answer. It's very challenging because you actually have to schedule it, and you either have to hard code where to move the data if you understand your workload, to move it into SSD, to move it into nearline SAS, or to move it into slower storage. And it usually recalculates only once a day or twice a day. And sometimes, by that time, you have already moved on to another workload that really is taking over during that time. So you never really catch up and get the optimal performance. One of the questions that we usually ask is, can I have a system that can dynamically assign performance to my LANs as they need it, right? If one day this SQL Server needs it, this afternoon another SQL Server needs that, or even my hotspots move around. Can this performance be dynamically assigned, and can your storage do that for you, right? We'll cover that a little later, yes.
Okay. As it stands right now, we all know that these workloads constantly change. Usually the hotspots are a lot smaller subset of data than what we've actually got. constantly archiving data, growing these data sets. You have to keep it all online in some fashion, for end-of-month reporting, end-of-year reporting, all these things. When you consolidate all this, you have that much more to worry about. And I take a really good look. I've done a lot of development work around SQL Server 2014, and they're not saying it, but functionally, SQL Server 2014 with the in-memory OLTP features, it really does depend on SSD. The bottleneck truly does shift into memory when you go do this, and that's really fast. Problem is, if you want that data to persist between SQL Server reboots or restarts, you got to be able to write any data change to disk as fast as humanly possible. And then when you restart that virtual machine, you've also got to be able to read all that data as quickly as possible back into memory before that thing can start up. So they're not saying it, but you have to be able to do all that as quickly as humanly possible, or else you're basically wasting that feature and just making things more complicated. Scary thing is, traditional all-flash arrays are really expensive, or flash caching for an existing array is prohibitively expensive. For me as a DBA, I really, really get behind the hybrid approach because you really can scale by IOPS or capacity or both. So if you need more raw performance, you can add more flash. If you need more archival data, you can add an additional tray of regular disks, and it just works. So Peter, I'll let you run.
Yes, gentlemen, so what we define as a flash-driven storage to solve some of these challenges around virtualization is something that can give you high IOPS and a low latency for both read and write. Something that does, very sophisticated inline deduplication compression to boost performance for the virtualized SQL Server. Not necessarily for the SQL Server data, but for the virtualized instances. You can fit 20 of them into the same space that you would fit one of them. So you get tremendous savings there. And you also get savings with backups and replication and all of those other things we'll cover a little later. And one interesting thing that, Tegile flash-driven storage brings, it changes a LAN from being a set of disks into being a set of resources that are dynamic. And each LAN or each volume that is exposed to you and given to you as a SQL Server drive that you can save your data into, or your tempdb or your log file, is actually composed of memory, flash, and if you want to, a SAS hard drive for the data that you may not go to very often. Think about it as a single data file that you would have for SQL Server. Some of the data in the data file is very rarely accessed if it's 5, 6, 7 years old. Some of the data that's 5 days old is accessed very often. So you would expect it to be in a higher level in Flash. And then some of the data is accessed all the time, like indexes, rebuilds, column store indexes, and those kind of things. And you would like those to be obviously in the fastest possible storage that's there, which is in DRAM, right? David, jump to the next slide, please.
Okay.
And let's move past this as well. So, I just want to introduce Tegile, if you give me just a minute. We were founded in 2010, about 2 years in development, launched in February 2012. Really, rapid growth in both customer base and the systems that we have deployed. We won top 3 storage awards from both VMware, CRN, and some other companies that do independent research. We are very well funded, August Capital, Meritech, and we are part of HGST and SanDisk, who are strategic investors. You know that HGST is a consortium, Hitachi Western Digital. They actually produce a lot of the SSDs. They produce a lot of hard drives, some new technology as well, like the helium drives. And they obviously have also acquired Verdant, which is a PCIe cards company, and those, they'll be coming out with PCIe drives that will be obviously integrated into our arrays later on. Let's jump to the next slide. Some of our sample customers, you can see that we are really, really well represented in many different industries, telco, financial, construction, consulting, very strong in education and state and local government. A lot of universities are using us for SQL Server virtualization, Exchange, SharePoint, all of those things, and some big names too. Virgin America, GoGo, Tesla Motors, Aer Lingus, using us for heavy SQL Server workloads on that side. Let's jump to the next slide. Just an overview of some of the awards and our certifications. Certified for Windows 2012, 2008, Hyper-V, SQL Server certified, the same thing for Cisco, Citrix, and VMware Ready. And we have a very deep integration with VMware as well, integrated into vCenter, using their API, so you can actually control the array from the vCenter. Your admins can do it. You get per VM workload reporting, meaning you understand how many IOPS is specific VM taking. So it's very, very effective to do some of the stuff that David was talking about, which is sometimes very difficult to tease out on a traditional storage media. What VM is actually using the IOPS and how it's represented on the storage array. Here is just an example of what we have for SQL Server. Obviously, there is a big page on our website. We are certified on the Microsoft website on the SQL Server reference architectures, and there is a link that you will be able to go to. We have several solution briefs that explain how does it actually work, both for data warehousing and OLTP, the throughput and the IOPS that you should be getting. And some of the throughput is truly, incredible, going well over 2 gigabytes a second, especially when you go into some of our stronger arrays. And then some of the, top reasons to use us. But we've gone past that. We've actually developed technical how-to guides that explain how to go from the system being set up and configured and connected to your servers to having high-performance SQL Server deployed and ready to accept your data, meaning load your data into it, in about half a day. And there are truly 30 pages, screen by screen, that show you how to do that. The first 10 pages of the technical how-to guides really explain the technology, all of the great features that are in there. We also have best practices guides around SQL Server, how to configure it and set it up. So you as a SQL Server DBA can actually understand and collaborate with your storage admin to make sure that you are getting the best performance out of your physical or your virtualized systems. And we are obviously always available to help with that. Very well, this slide will build. So this is what I was explaining in the beginning. So a legacy volume is usually a set of disks, implicitly defined performance, meaning number of drives times IOPS per drive. There is usually a small RLU cache, which is least recently used cache, very simple logic, usually doesn't actually cache a lot of data that's useful, and that usually lives on a controller. Those controllers can be, 20 to 80 gigabytes of space. Some of the very expensive VMAX have little more, but it's shared across the whole array. It can be 400 or more terabytes of data. All of the metadata around the data is also stored on the spinning media. So they're actually duplicating access. You go there once to figure out where the data is, and then the second time to actually fetch it. It is somewhat complex to add and remove performance out of these LUNs once they are created. And you probably know that, guys, from experience with your Visual Storage team. It's not easy for them to do it. And more importantly, all data on these drives, on these LUNs or volumes, is treated equally, meaning the 5-year-old data will be as fast as to get to as the 5-day-old data, right? Unless you happen to, for your index to be cached in the LRU cache for a few minutes where it speeds it up. It's very difficult to distinguish in between that. Can you do a build, David? Very well. So this is what Tegile really delivers. It delivers integrated memory, flash, and spinning media if you want to. And this is the true hybrid approach. So the data that you need the most often is always in DRAM and flash and compressed on the drives. The data that you access very often is in flash, and it's also there is a copy compressed on the drives. And the data that you go to once a day, twice a day, you get 5, 10 millisecond access time to the spinning media. And you get the data, it's available. You don't have to move it anywhere. It's always there. But it's you can access it, but it's not taking space in your valuable DRAM and in your valuable flash. With all flash, while you get really, really great performance, and we offer fantastic all flash arrays, all of our technology can be extended with hybrid after that. Because usually people end up using, 4 to 40 terabytes of data a day. They are not going to use 400 or 500 of terabytes. So, proposition from all flash companies telling you that you need flash for everything can be somewhat exaggerated. Can you build, David? And build one more, please. So this is what really happens with OLTP. So your index is column store, and the most used data out of your active tables, out of your partition, will end up in DRAM and be served out of that. Then your active use data that you actively use for OLTP, and this can be anywhere in between 4.4 all the way to 40 terabytes of flash in a single shelf, will be probably cached and sitting in there. And then persistent copy will actually be on the spinning media. You will probably share this array with many, many other databases and many, many other workloads. And there is more than enough space to give you the right performance for all of those. And then the data warehouse and BI will obviously be similar, except that maybe the active portion of the data warehouse, the last month, the last quarter, the kind of things that you go to most often will be actually living in flash. And your historical data will actually be then only sitting on spinning media. But that's what you actually want. You want cheap spinning media for that. Still be very accessible, still be able to get to it. But you don't want to obviously pay, $10 a gigabyte to store the data in there. David, let's move on to the next one. So this is, some of the information about how you can actually extend this, right? So it's highly available, it's fault tolerant, everything is hot swap in the system, and you can start with all SSD shells, or you can start with a controller that's already hybrid, meaning mix of DRAM, flash, and spinning media. And you can always expand it with either hybrid, all SSD, all spinning media only. And this is the fantastic thing that you can do with us, is that you can start with something that's very, very high performance and gives you 20 terabytes of space, 4 terabytes of space in flash. And then over time, you can extend it with spinning media because you know that that's really all the data that you will be using actively is already covered by the controller. So decoupling the IOPS performance from the space is what we really give you there. And the flexibility of reassigning the DRAM and the flash dynamically to whatever volume needs that specific performance, during that time. So the data isn't actually tiered, it isn't moved in between, it's a real-time cache that actually takes care of that. David, next slide. And we are almost at the end of the presentation here. I think we really have just one slide. Here are some of the configurations that are available and that we have deployed, and they are certified by Microsoft. And a lot of these are, really for you, which is tiny. That's like 4 pizza boxes stacked together. That's the whole size of it. And you can get things that are certified anywhere from 20 terabytes and have maximum capacity of 50 terabytes and about 80,000 IOPS. That covers 90% of the scenarios, all the way to something very, very high performance that's certified at 25 terabytes by Microsoft with maximum capacity of 85 terabytes for your data warehouse and giving you 280,000 IOPS. Obviously with the middle tier at about 110, 115, and 40 terabytes of maximum capacity. So really you can configure, our product line is very flexible. So you can configure what you want, and you can configure it in a way where you can share it with many other people, meaning with the Exchange guys, with the SharePoint guys, and still guarantee performance for yourself. We have some fantastic features. We are integrated with Microsoft both CSV, which is cluster share volumes, and VSS, which is volume shadow services. And that allows us to do application consistent snapshots of SQL Server and all of your other Microsoft applications, including when they are inside VMware. Guys, don't be fooled by this. When somebody says, oh, we do application consistent snapshots of VMware, and they have it with VMware, that doesn't mean anything. VMware doesn't actually understand that SQL Server is in the middle of writing a table. It just makes sure that it takes a snapshot where VMware can start up that snapshot. But it doesn't mean that your SQL Server was finished, done writing. For that, you really need, the vendor needs to give you a VSS driver, Windows Volume Shadow Services. Because we have that, our snapshots, when you take a snapshot, it takes about a second. And you can then expose it in another 20 seconds as a new volume that is both readable and writable. And the original volume is still readable and writable. And it didn't take any extra space on the array. Imagine every time somebody comes to you and says, can I get a copy of the production database because I need to run some tests, for QA, for pre-production. for the dev guys. And you know that it's going to take you a day or a half a day to actually get it done. With us, you can do it in 21 seconds, and you didn't take any new space on the array. Only the deltas, as people will start writing into those files, will be actually saved. We use this technology for replication as well, meaning we take those snapshots and we ship them off to a secondary array, and it can be either in your colocation facility, or it can actually be somewhere in the cloud. And this is, additional feature to provide out-of-region failover, where, always on would be very difficult to use because maybe there is too much of a distance and there would be too much of a delay. I've already told you about our inline deduplication for virtualized SQL servers and all of your virtualized workloads, where we actually deduplicate the content itself, meaning the actual images, and they shrink significantly. We can get to 40, 50% deduplication, saving a tremendous amount of space. And one additional fantastic feature, deduplication for SQL Server backups, meaning you always have to do full SQL backups once in a while, no matter what, to make sure that you can restore properly, right? Once you do the backup, it's very, very big file. If you back it up to the same volume where you have turned on our deduplication on, the additional files that you are saving, only the new pieces that are not recognized as previously being saved will be saved. But, to SQL Server itself, it obviously seems like they have resaved all of the data. All of the data is accessible in 2 different files. It looks just like if you have saved all of the data twice, but the duplicates have been removed and they are actually not there because there is no need for us to save the data several times. There is already high availability and fault tolerance built into the array, so you don't need to save it multiple times. And I think, David, that really concludes our presentation here.
Cool. If there's any questions on any of the topics that we talked about, definitely let Peter know. He'll definitely route any of the technical questions on to me, and I will be very, very happy to answer any questions that you have.